Hello, let's look into today's Leetcode problem, which is special array 2. In this question, you are given with two inputs, nums and queries. And what you want to do is determine if a subarray is special or not. So the queries basically specify the subarray. Let's walk through the question first. So an array is considered special if every pair of adjacent elements contains two numbers with different parity. With different parity, what they may mean is if one number is odd, then the other number should be even. If one number is even, then the other one should be odd. So if you find all of the elements following the pattern of different parity for a subarray or for an array, then you are going to term that subarray as special. So you are given with an integer array nums and 2D integer matrix queries, where queries of I basically means you will have to check for the special subarray scenario for a subarray starting from this index to this index. If it is special, then you are going to return true. If not, then you will be returning false. Let's try looking into one of the examples here and understand about this question a little more. By the way, the question is pretty straightforward, so we can walk through it very quickly. So here what they are trying to ask us is try checking for the subarray starting at index 0 and ending at index 2. Index 0 and index 2. Here this is index 0, this is index 2. So the subarray will look like 431, and we will be checking if all of the elements, adjacent elements follow the different parity case. So 4 is an even number, 3 is an odd number, well and good. 3 is an odd number and 1 is also an odd number. So here these two elements are not following the property that we want it to follow. So which means we should be returning false for the subarray. Now let's try looking into the second subarray, which starts its index from 2 and ends at 3. 0, 1, 2 and 3. So the subarray will look like 1, comma 6. So for 1, 1 is an odd number and 6 is an even number. So we can consider this subarray to be special. So in that scenario, we will be returning true. And in the answer, that's what they are returning here. Let's look into the first example as well. So here 0, 1, 2, 3, 4. Here they are taking the entire array to be the subarray, and if you try looking at the inputs, right, it is odd, even and even. So here the last two elements do not follow the property that we want to. That's the reason we are returning false here. So, and one more thing that we should look into is the constraints. Here, uh, the constraints are kind of big, so you should actually come up with a good solution, which can either be of big O of n, or it can be lesser than big O of n if it's possible. If anyone comes into this problem, the brute force approach that they should think is for each of the subarray, we do the checks. So here a subarray is formed, and like I did the dry run, we will be checking for the adjacent elements for the subarray. Let's say 4 will be checked with 3, 3 will be checked with 1. Similarly, 1 will be checked with 6. So for every query, we will be doing this check. Now, someone might say that we are doing it in linear time because we are only iterating one time in both of the scenarios. But let's consider an example, right, where you have a subarray starting from 0 to, let's say, 99, and a second array starting from 1 to 99. In that scenario, it will be a lot better if we try storing intermediary results, right? So here we have already done comparison of like say 100 or 99 elements here, and an extra comparison that we will be doing here is basically we won't be doing an extra comparison here, but we will be removing that extra comparison from this comparison, and we will be able to get an answer instead of doing one more iteration, one more round of iteration. So in such kind of problems, right, prefix sum should be thought of, and that's the solution that I have followed. So what I did was I simply took a count of disparities. Not disparities. In this scenario, we should be checking for parities. If we have two adjacent elements having the same parity, then it will indeed be a disparity for us. In other words, it will not be a special subarray for us. So that's what we do here. So let me try to make it little bigger. Let's add few more numbers here. 6, 5, and 3. Okay. This is our array here. And what we can do here is we will try comparing. We will do only one linear order traversal here. So 3 will be compared with 4. Initially, we will set the prefix sum to be 0 for everyone. Now comes the comparison. We will compare 3 with 4. If both of them are having the same parity, they are not having the same parity, then we proceed forward. We will also have a local variable called count, and whenever we find two neighbors having the same parity, we will be increasing the count. So now 1 will get compared with 3. Both of them indeed do have the same parity. I might have missed it in the previous example. I'm not sure about that, but they do have same parity. So we will increase the count to 1 and we will point 1 here. And now 6 will get compared with 1. 1 is odd, 6 is even. But we are calculating the prefix sum over here. So count will remain the same and we'll put it here. 6 and 5 will be compared. 6 is odd, 6 is even, 5 is odd. We are good to go here as well. And again, 3 and 5 will also be compared. Both of them are having same parity. In that scenario, our count will get increased one more time and our count will be 2 here. So let me cross check. 4, 3 having different parity, 3, 1 having the same parity. That's why we have one count here. 1, 6 having different parity, that's why we maintain it. 6, 5 having different parity, we maintain it. 5, 3 having same parity, that's why we increase the count again. So this is our prefix sum array that we have come up with. Now if someone asks me to search for a subarray, say if we want to check if the subarray is having a special case or not, then what we simply do is go to that index, 0th index, and go to the second index, 0, 1, 2. This is our second index. So we simply subtract both of these index. 1 minus 0 is equal to 0, which means in this subarray, somewhere down the line, I was able to find one same parity, because of which I can see the difference to be 1 or not 0 basically. If the difference is not 0, then we can pretty much say that the array has some elements which whose neighbor has the same parity. Similarly, let's try checking out for 2 and 3 as well. So for 2 and 3, the example that we have has been extended. So okay, so 2 and 3 will be 0, 1, 2, 2 and then 3. So we are going to check for 1 and 6 here. So for 1 the prefix sum is 1, and for 6 as well the prefix sum remains the same. And if we do subtraction, which it means that we were not able to find any element in this subarray that has same parity, because of which the count never increased. If the count never increased, that means in that subarray we are having all the elements having different parity. That's why we will be returning um, true. That is, we have a special subarray here. For this query 0, comma 2, we didn't have a special subarray. That's why we will be returning false. Let's try adding one more query, right? And try to validate our example. Let's say we want to do comparison from 6 to 3. Then what we do is the same thing. We will go to the last index of that subarray. We will check for its count 2, and for this index we have a count 1. 2 minus 1 is equal to 1, which means in this subarray somewhere down the line we have one pair that doesn't follow the different parity thing that we wanted to, which is 5 and 3. Obviously we can see it, so we'll be returning false here for this subarray. So I think we are good with these examples. I have walked you through these many examples, so we should be good here. So let me walk through the code as well. So I have declared a prefix array of size n, n being the length of the array. Then what we simply do is do one linear iteration. That's it. So we start from 1 because we are going to compare it with the previous element. So we will be checking if 1 is even. If it's even, then we want the left neighbor to be odd. If 1 is odd, then we want the left neighbor to be even. If any one of these conditions satisfies, right, then we can say that we are having disparity in the neighbors. So if we do negation of the complete condition, then it means that two neighbors are having the same parity. If two neighbors are having the same parity, then we are going to increase the counter by 1, and then we will be setting the prefix I to that of count. And in the end, what we do is for each of the subarray, we will be calculating the difference. And if the difference is not 0, then we are simply going to say that we found some elements that has the same parity for their neighbors. If both of them, the difference between the start and end point remains the same, I mean 0, then we are simply going to say that the subarray is having a special case, special scenario. And in the end, what we do is we return the result. So this question was very straightforward. Um, if you are well versed with concept of prefix sums and all, then it would have made your time complexity better. So yeah, that's it for this solution. I would actually say that this question could come under easy as well, but here we are using a concept prefix sum. If someone might not know, they might have missed it, and I haven't tried the brute force approach here yet. Maybe it might give me TLE because of the time constraints over here. But if you do it the prefix some way, then it will be good. You won't be getting any TLE. Like I did some submission early on. So yeah, thanks for watching. Bye bye.